Let's now take a look at routing inside of Azure, and to begin with, let's look at the system routes. Every subnet that you create has a route table that at a minimum contains the following routes. The local VNet, this is the route for local addresses, and so there's no next hop value. On premises, this is the route for defined on-premises address space that you might have in your main data center in your premises, and the next hop will always be the VNet gateway, which traverses the traffic to your on-premises data center. And finally, you'll have your internet route, and this is a route for all traffic destined to the internet, and the internet gateway is always the next hop address here. The default routing in a subnet is as follows, and if you look at the diagram on the right, it gives you the three major use cases, but we'll break them down a little further. One, if the address is within the VNet address prefix, we just route to the local VNet, so we have implicit routing for VNet addresses. If the address is within the on-premises address prefixes or BGP published routes, we route to the gateway, and this is implicit routing for on-premises address on the left-hand side there. If the address is not part of the VNet or the BGP or LSN routes, we route to the internet via NAT. And then finally, we've got two more. If destination is an Azure data center address and express route public peering is enabled, it is routed to the gateway. Or if the destination is an Azure data center, but we're using site to site or an ER express route again without public peering enabled, it is routed to the host NAT for internet path. However, it doesn't actually leave the data center. Going a little further, we can also define user-defined routes. So if we look at this, this is our typical scenario with system routes that we kind of described before. And you can get more information on this by selecting the link below. But to go a little bit further, let's see what happens if we change something like this where we have our web servers and our database servers. Currently, they can talk to each other because they're in the same virtual network, so the system route works there between the subnets. But what can we do if we want to route them through, say, a Palo Alto or something like that, or another network virtual appliance? Well, we can input a user-defined route to stipulate that all of the traffic now has to flow through this virtual appliance. And that's effectively what a user-defined route is. We go into the route table section of Azure, we define it, and then we associate it, and we force all the traffic to the appliance. And you'll see that in the upcoming demo. Last but not least, we also have one other trick up our sleeves. When we want to connect one virtual network to another one, we can use something called VNet peering. And what this allows us to do is, say we have the hub of shared infrastructure services on the right-hand side, and that virtual network, we want to be able to route to services in, say, the customer apps VNet or the data services VNet or another VNet. Then we can simply peer the VNets, and that's effectively like joining them together so they can route within that same space. And now, the only problem we might have is if we want to go again, we can't daisy chain to a third one. So we can't say do another peer between customer apps VNet and another one beyond that. That won't work. It only works directly between two VNets. You can't assume that it daisy chains along the line. But that's it for routing and VNet peering. Check out the upcoming demo, and hopefully that will solidify all your knowledge in the space.